Hello and Namaste. In continuation with the double integrals, we'll be dealing with the evaluation over a general region part 2. So in the part 1, we have discussed in detail how we have to go about the vertical strip or a horizontal strip. So in this particular session, we'll be dealing with different type of examples. So first one, evaluate double integral x plus y dy dx where R is the region bounded by x is equals to 0, x is equals to 2 and y is equals to x and y is equals to x plus 2. That means here in this particular example we'll be dealing with x is equals to 0, x is equals to 2 as these two curves and y is equals to x and y is equals to x plus 2. These are the two curves. So four different curves we'll be dealing with. Now if we'll talk about each and every curve, so x is equals to 0 is nothing but an equation of a y-axis. If we'll talk about x is equals to 2, which is a line parallel to y-axis and it passing through x is equals to 2. Third one is y is equals to x, which is a line passing through the origin. And the fourth line is y is equals to x plus 2, that is nothing but x minus y is equals to minus 2. We can rewrite this. Why are we rewriting it? Because we wanted to find out the points of this particular line. So if we x minus y is equals to minus 2, if we put x is equals to 0 here, if I'm putting x is equals to 0 in this equation, so we'll be getting y is equals to 2, that is what here. And if we are putting y is equals to 0, this one, then we'll be getting y is equals to minus of x is equals to minus of 2. These are the 2 points. That means what? We'll be getting this 2 point 0 comma 2 and minus 2 comma 0. These are the 2 points to draw a line, and we know that to draw a particular line we need at least 2 points to draw that line. That is what we are doing this exercise of making this rewriting this equation, and after that putting x is equals to 0, getting the value of y, putting y is equals to 0, getting the value of x. Now whenever, because we have got it here, this constant is minus 2 is very small number. If we are getting this particular number is a very large number, at that time it would be difficult for us to draw that line in one plane. In that case you can just check the equation of a line and accordingly you can take the values of x is equals to something, y is equals to something, and then get the values of corresponding other two variables. Therefore, so as I have told you in the last session that we have to go about the method, and first of all we have to first identify all these four curves which are the given one. Then we need to find out the points of intersection of all of them. So first of all, if you consider x is equals to 2 and y is equals to x plus 2 as this line, then we need to understand and we need to find out the point of intersection of this particular line. Let us find out. So if you observe, x is equals to 2 and y is equals to x plus 2. So in this particular second equation, if you put the value of x, so that means what will we get? This x is equals to 2. That means at x is equals to 2, we'll be getting the value of y is equals to 2 plus 2. That is 2 plus 2, that is equals to 4. So we have got the point of intersection of this particular line as 2 comma 4 as the point of intersection. If we talk about the another two curves, that is x is equals to 2 and y is equals to x. So if we put x is equals to 2 in this case, so we'll be getting y is equals to 2 because the curves are very simple, and therefore we'll be getting the point of intersection as 2 comma 2. This is the point of intersection from this second curve. Then that means if you observe this particular curve, so we have identified 1, 2, 3, 4 curves. We have got there the point of intersections as well. Then we need to draw all of them in a plane. So x axis, y axis, this x is equals to 0, that is a y axis. If you observe here, x is equals to 0, this is what is given here. X is equals to 0, x is equals to 2, this is the second curve. Third curve is y is equals to x, and the fourth curve is y is equals to x plus 2. So these are the 1, 2, 3, 4 curves have been drawn in the curve, in the plane, and after that according to this particular point of intersection we can just put the point of intersection over here. So this is origin is 0 comma 0 as a point here. So point O is 0 comma 0, point P is 2 comma 2, that is what the intersection of x is equals to 2 and y is equals to 2, the x line. So this is x is equals to 2 line and this is y is equals to x line. The point of intersection is P over here. Then we have got this 2 comma 4, which is a point of intersection at x is equals to 2 line and y is equals to x plus 2 line. That is the point of intersection is Q over here, which is nothing but here 2 comma 4. and this point R is nothing but 0 comma 2, which is what we were talking about to draw this particular line. We have drawn this particular line with the one point is this minus 2 comma 0, another point is 0 comma 2, and now we need to identify which region, because we need to have 1 2 3 4, all the 4 curves should come together at one place, and this is the only region we have got it in this. So this is what is the region which is shaded with the blue color, is the region of, you can say, the convergence or the region of consideration here. Now in this particular case, as you can easily say here that I have drawn here a strip parallel to y-axis. Why? Because we have a two choice. We can go for parallel to y-axis or a parallel to x-axis. The strip, or you can say a vertical strip or a horizontal strip, it's up to us. Why we have considered here a strip parallel to y-axis? Let me explain you with this. Now I have drawn the similar type of region over here. Now in this region, suppose we are considering a strip parallel to x-axis. That means what? We know the convention, whenever the strip is moving, it will be always move from down to up. That means we have to start the strip from here. So suppose we are starting with the strip over here, then it will come till over here. So this strip will come. Whenever this particular strip will pass this particular point here, what will happen? Because of this point R, because of R 0 comma 2 point, and what is this point? This is the origin, 0 comma 0 point. Now if you observe here, this strip parallel to x-axis, this particular end is lying on this curve. What is this curve? This curve is x is equals to 0, and another curve is lying on this particular curve. What is this equation? It's y is equals to x curve, right? But whenever it is passing through this point R and going upwards over here, that time, let me just do it here, yeah. So at that time, what will happen? This, if you'll observe here, this strip over here, this side of end of this particular strip is lying on y is equals to x plus 2. This line, that is this line, wherein this line is still the another part, this point is still on y is equals to x line, right? And again it will come to this particular point, which is a P point, 2 comma 2. Again it will change the other end of the strip. That means if it is coming over here after crossing this point P, so it's crossing the point here. This is one partition, this is the another partition happened, and if this strip will come over here, it will give rise to another curve. This end is still on the curve y is equals to x plus 2, but this another curve, another end is changed for y is equals to x to this particular line, that is x is equals to 2, and that's the reason we cannot go ahead with this, and because we need to solve 1 2 3 integrals. Cannot go as in we can go for this type of example, this type of curves, but in this case you need to find out I1, I2 and I3. These are the three cases you need to solve. These three integrals you need to solve in this case, and that's the reason it is advisable, or you can say it's a good choice to go with a strip parallel to y-axis. So that's the reason we are considering here a strip parallel to y-axis. And if you are considering a strip parallel to y-axis, we know that the lower end of this strip is lying on the curve y is equals to x. So the limit of y is x to another end is here on this curve. So this is the one curve, lower end. This is the upper end is here in this curve, that is y is equals to x plus 2. So y is moving from x to x plus 2, wherein x is moving, if you'll observe here, this coefficients, this origin coefficient is 0 comma 0, and this particular curve is nothing but x is equals to 2. So that means what? This x is moving from 0 to 2. So this is also one of the way to just check it out. 0 to 2 would be the limit of this particular x over here. And therefore this I can be written as in this way, and in the next slide we'll be going ahead in the detailed solution of this particular integral. So therefore in this I is equals to from 0 to we have seen that this is y is equals to and this is x is equals to, let me just yeah, Okay, and therefore this is just we are finding out the inner integral, that is with respect to y. It's a very simple, just because it's a x plus y, so xy plus y square by 2. Just putting the upper limit and the lower limit, simplifying further, we'll be getting this answer like this. Just go through this because I am concentrating on that, because it's a very simple type of example. I have taken it here, and if you have any doubt in evaluation part, please do follow the session wherein I have just discussed about the evaluation of an integrals. Okay, so the second question goes as 2x minus y square double integral over r dA over the triangular region r enclosed between the lines y is equals to this. So that means what we have got it here. First of all, we have understood that this is been given to us as a triangular region, and y is equals to minus x plus 1, y is equals to x plus 1, and y is equals to 3. These are the three different curves that have been given to us. So talking about that, first curve is y is equals to minus x plus 1, that is x plus y is equals to 1. That means we are getting it again the same rule what we have done it. To find out or to draw the line, we need at least 2 points. So these are the 2 points we have got it. Just putting x is equals to 0, we'll be getting y. Then after putting y is equals to 0, we'll be getting x as 0, 1 and 1, 0. These are the two pairs of the points. Then the second line is this one we are talking about, y is equals to x plus 1, that is x minus y is equals to minus 1. Again the same logic will apply, whatever we have done it here. The same way we'll be getting 2 points as 0, 1 and minus 1, 0 are the two points to draw a line. The third curve has been given to us as y is equals to 3, that is a line parallel to x-axis and which is passing through y is equals to 3 as a point. And therefore we need to find out the points of intersection. Now finding the points of intersection here, we need to first consider y is equals to minus x plus. That means we'll be finding out the intersection between these 2 points, these two lines in fact. So y is equals to minus x plus 1 and y is equals to x plus 1. So if you'll do this type of thing, so if you observe here, LHS are equal, so RHS have to be same. So minus x plus 1 is equals to x plus 1. That means you will be getting is 2x, right? This is, so the x is going to this side, this is coming, so 2x is equals to 0. That means x is equals to 0. So if x is equals to 0, sorry, we'll be getting x is equals to 0. Putting this value over here, we'll be getting the corresponding y. We'll be getting the corresponding y of that. So x is equals to 0. So if we put x is equals to 0, y is equals to 1. So we have got the intercept as 0, 1 as the intercept of this particular two lines. Then the second line is, the second line is y is equals to x plus 1 and y is equals to 3. Again y is equals to 3. If we put y is equals to 3 ultimately, that means we are getting 3 is equals to x plus 1. That is, we'll be getting x is equals to 2. So we have got the point 2, 3 as the intercept of these two curves. Then looking at the third one, y is equals to minus x plus 1 and y is equals to 3, we'll be getting this intercept. So y is equals to 3. So this is 3 is equals to minus x plus 1. So that means what? This is 2 is equals to minus 6. So x is equals to, right? X is equals to minus of 2. So we have got the point as minus 2, 3 as the intercept. So if you'll observe here, the y is equals to, so we'll be observing this 0, 1, 1, 0. We have got this line. So y is equals to minus x plus 1. These are the two intercepts. If you observe here, this is 1 and this is the another intercept. What we have written it here. Another line is y is equals to x plus 1. That is the intercepts are 0, 1 and minus 1, 0. So this is minus 1, 0, 0, 1. So these are the two lines. The another third line is y is equals to 3 is this particular line, the horizontal line. If you observe here, this is y is equals to 3 line. So we have got this also one of the line. As let me just highlight so that you can have this as the thing one. So we have got these three different curves and we have got this triangular region. We have got the intercept 0, 1 as the intercept of these two lines. And then we have got 2, 3 and minus 2, 3. These are the two intercepts of respective these two curves. Now looking at this particular here, if you'll observe here, I have drawn here a strip parallel to x-axis. Why not to go for a strip parallel to, sorry, we have drawn it here, strip parallel to x-axis. Why not to go for a strip parallel to y-axis? Let me just explain you. I have just drawn this particular region again here. So as I have told that whenever we are moving for the strip parallel to y-axis, we have to always start from the left hand side. So that means we will be coming to this region here. And suppose we are drawing this particular strip over here. If you observe this particular strip here, this is y is equals to 3 line, and this is another one is y is equals to minus x plus 1. This is a particular line. But whenever it is coming to this point, which is a point P over here, and this is because, just a minute, because it would be very simple for us to have this partition. Right, because of this point P, what is happening here, whenever we are moving ahead with this point, we'll be moving to the different curves over here. If you'll observe here, the lower end of this particular curve, the strip is shifting from y is equals to minus x plus 1 to y is equals to x plus 1 line, wherein the upper limit is the same, that is y is equals to 3, and because of that we need to solve here two different integrals. To avoid that, we have just taken here a strip parallel to x-axis. As I have told you in the last session also, you have to consider a strip parallel to x-axis. That means a horizontal or a vertical strip. According to your integration will become easy or simpler. So this is what is the reason we have not considered a strip parallel to y-axis. We have considered a strip parallel to x-axis, or you can say a horizontal strip we have considered. Now if you have considered a horizontal strip, if you'll observe here, this end, so horizontal, this particular end of this curve is lying on y is equals to this x, because it's a strip parallel to x-axis, so x is equals to minus y plus 1 to the another curve is here, this end is here on this particular curve. What is this? Y minus 1 is the curve over here. Similarly, how this x-axis will, this limit of y will move like this, because it's a y, right? So because it's like this 1 2, if you'll observe, this is the end of this y, and if you'll observe here both the sides, because of this particular line, it's 3 over here. That means y is moving from 1 to 3, and therefore we have got this type of integral over here. So now we'll be solving this integral in the next slide, and I'll be just moving ahead with a very fast pace, because it's a very simple one actually. Yeah, okay, yeah, I think I have made a mistake here. It's not this, this is this 2 over here, it's not here, right? So because if you'll observe here, it's 2x minus y square, right? Please make the change over here. It's 2x minus y square dx dy. It's not to the whole square. Okay, so moving ahead, it's a very simple one, 2x minus y square. So because it's x, we are doing it, so we are integrating with respect to x, so x square by 2 will go off, minus x y square, and limit will move in, and then after that, just by simplifying further, you'll be getting, because it's a very simple integral, I'm not going to put my time into this. And then that's all. This is about the self-observation slide. 1 2 3 questions have been given along with the answers of these 3 questions. Please do solve these examples. If you have any query, put me in the comment section that this is what is you are getting. If you are getting help out of this sessions, or you want me to improve on further with this type of presentation or something like that, please let me know. And thank you so much. Happy learning.